All right, the big problem. All right, so if you're here, it's because you want kind of help on this and you want a chance to be successful on this problem. So it is pretty much the exact same, but I just use different numbers here, okay? But the idea behind it is the same. Okay, so the next door neighbors, Coach Graham and Coach Langford, are planting their spring gardens. Each will construct a rectangular garden surrounded by a chain link fence. The length of Graham's garden will be 12 feet more than 2 times its width. The length of Langford's garden will be 2 feet less than 3 times its width. The widths, W, of both gardens will be the same. So here's my help to you is always draw a picture. So if we draw a picture, this being Graham's garden, so G, this being Langford's garden. Okay, so let's talk about these statements right here. So Graham's garden, its length is 12 feet more than 2 times its width. Okay, so 12 feet more than is adding 2 times its width. Okay, so we have 2W, okay, and then a plus 12, okay? So here's the thing on what order you put it in. Because of this word right here, than is known as a switch word, meaning whatever comes after than now goes first, and whatever was stated before is now last. So instead of 12 plus 2W as my length is actually 2W plus 12. So my length is 2W plus 12. And my width is just W because my width is being multiplied by 2 and added 12 to get to the length. Coach Langford's is 2 feet less than 3 times its width. So 2 feet subtraction is less than is our switch word. And then 3 times its width is 3W. So instead of 2 minus 3W, it is now 3W minus 2. And then her width is also W. Okay, so that is how you would get our dimensions, okay, our length and our width. It says write an expression to represent the perimeter of Graham's garden and the perimeter of Langford's garden. So perimeter is adding all the sides. So would you agree that opposite sides are congruent? So this is also 2W plus 12, and this is also W. This is W, and this is 3W minus 2. So in order to get my perimeter, so Graham's perimeter, we would have 2W plus 12 plus W plus 2W plus 12 plus W. Okay, well, we don't want to say it like that. That's too much going on. So we're going to combine our like terms. So we have a 2W plus W, a 2W plus W. So all together we have 2, 3, 4, 5, 6 W's. And then we have 12 and another 12. So we have plus 24. So Graham's garden is 6W plus 24. So that's Graham's garden. And then we have Langford's garden. Well, Langford's perimeter is 3W minus 2 plus W plus 3W minus 2 plus W. So again, we're not going to write it like that. How we're going to write it is our W's are going to be combined together. So we have 3, 4, 5, 6, 7, 8 W's all together. And then we have our constant. So we have a -2 and another -2. So altogether we have -4. So Langford's perimeter is 8W minus 4. So that's the end of part A. Part B says use the expression from part A to write an equation that represents the perimeters being equal. So literally, Graham's perimeter equals Langford's perimeter. So Graham's perimeter was 6W plus 24. Langford's perimeter was 8W minus 4. So therefore, here's the answer for part B. Part C says use part B to solve for the value of W. So I'm going to rewrite part B, our perimeters being equal to each other. And now I'm going to solve. So we have a variable, a constant, a variable, and a constant. So I'm going to move my variable to the left. So I'm going to subtract 8W. 6 minus 8 is a negative 2W. Bring down what I didn't use. That is a negative 4, so I'm going to make sure I bring down the negative sign as well. And then I'm going to subtract 24. I'm left with negative 2W equals negative 28, because negative 4 minus 24. And then we're going to divide by negative 2. So negative 28 divided by negative 2 is 14. So the width of both of our gardens is 14 feet. Okay. All right. I hope this helps. Good luck tomorrow.